Fix it. Am I good to go?
Yes. Just check once. Yes.
Good afternoon, everyone. First, thanks to IndoML for this wonderful opportunity to present research and discuss with so many early career researchers and also learn about research of so many pioneers in the field. My topic will be reimagining machine translation and text classification to understand news media and politics. Before that, I'll try to give a very quick snapshot of what I broadly do. So broadly, my research has three connected strands. And in first strand, I work on the US political landscape. And there, my focus is both on the substantive questions and also methodological advancements to understand differences between large-scale text. In the second strand, I focus on international politics. And there, I have worked on many events of like a global consequence, like the India-Pakistan conflict, Rohingya refugee crisis, election in the world's largest democracy, and sustainability challenges. There, my focus is are on building a novel framework to counterbalance hate with positive content and democratizing NLP through low-resource NLP methods. I deliberately decided not to talk about this area because we have Animesh Mukherjee and Monojit Chaudhuri, two pioneers in these areas. So I decided to skip this second strand. And in the third strand, I work on minority-aware responsible AI. One interesting recent project was we looked at 70 years of Bollywood and Hollywood movies, and we wanted to see what kind of societal biases are present in these movies. And spoiler alert, we found that AI methods show that Bollywood has a tremendous obsession with fair skin complexion, and also it shows sun preference. In another related work, we showed that if you have prominent automated speech recognition systems and your input is a conversation between kids, they can often generate very unsafe and inappropriate errors. For example, here, Ryan is actually saying that you should also find porn, and the ASR system is predicting you should also find porn. And we call this phenomena as inappropriate content hallucination. And when this work received a lot of attention, the best part was YouTube actually fixed some of these high-risk unsafe errors. So some of my research has also initiated platform-level changes. So with this quick intro to my work, today I'll be talking about three simple ideas. And each of these ideas try to accomplish one specific thing. So one is how to quantify ideological differences between large-scale text discussing a multitude of issues, how to quantify text differences between small data sets focused on a single issue, and finally, how can we curate a more robust misinformation data sets. So these are the three ideas I'll be talking about. Here goes the first idea, how to quantify political polarization on large-scale discussion data sets discussing a multitude of issues. This work is focused on the US political landscape, specifically on the build-up to the 2020 election. However, much before that, as this Pew Research survey suggests, that when over these last 20 years, when registered Democrats and Republicans are asked policy-related questions, their responses have become, for the Republicans, it has become consistently more conservative. And for the Democrats, it has become consistently more and more liberal. So you can see that there is already a growing polarization right from 1994 to 2014. The role of hyperpartisan news media and their partisan and ideological divergence in both content and audience, that's well documented. And in this work, we focus on four major US cable news networks: Fox, CNN, MSNBC, and One American News Network. Now, when I talk about, we focus on these cable news networks, we do not focus on the cable news network per se. Over the last few years, these networks have amassed a lot of subscribers on YouTube. These are the big three news networks, and you can see that they have millions of subscribers. We also included One America News Network, a conservative fringe news network, because it had a very special champion in the form of the 45th US president. So here is how the information is flowing. This is everything that's going on in the universe. And then a subset of that are events interesting to United States. Then we, different subsets, presumably with some amount of overlap, are interesting to these different news networks. Then they upload their news videos on their YouTube channel, and these videos reach a diverse pool of audience, again, with some overlap, but these sets are not identical. And these users engage with the videos through comments on those videos or liking or disliking those videos. So that actually gives rise to a very novel data set, which is pretty much a snapshot of modern US politics of 85 million user comments posted on more than 200,000 news videos on YouTube. Now, we kind of implicitly know that discussions on Fox News and MSNBC will be different. For those who do not have a background like in US, just think about Z News and NDTV. Their comments, user comments will be different. But how can we quantify these differences when people are discussing a lot of different issues over these unstructured text data sets? Polarization has been widely studied in social science. There are some seminal lines of work in political science where congressional votes have been used to measure polarization. A very famous work from Dan Jurafsky's group came in 2019, NACL, which presented a computational linguistics framework that specifically focused on quantifying polarization on mass shootings. And there also has been a rich literature in the network analysis side. Here, we are actually dealing with a very different research challenge, how to quantify political polarization on large-scale discussion data sets, discussing a multitude of issues. So this has been an unaddressed NLP challenge for years. And the way we try to solve it will require a little bit of background. So I'll first give a short detour of how machine translation works, and then I'll be able to describe how we address this challenge. If I say that here is a word car, and there are three columns, the red, blue, and black, which column is close to the word car? So if we take the right column, do we think it is close to the word car? How many of you think? Yeah. So it's because truck and ambulance are specific cases of car. Bike, not so much car, but it's still a vehicle with which we can go from point A to point B. How about the blue column? Is it also related to the word car? It is related to the word car because we have seen words in the blue column and car co-occurring in the same sentences often. How about the black column? You'll say that no, not so much related to car, right? So the idea is words are close if they appear in similar contexts. And they share context in two different ways. First is if it's a near synonym, like I went for a car ride, you can actually replace the word car with bike, and you will still get something that makes sense. So that's how near synonyms share contexts. For the words in the blue column, they share context with car by co-occurring in the same sentence with car. In 2013, a breakthrough result came from a group of researchers who managed to assign points in high-dimensional space to a large number of, process a large number of text and assign points to a high dimensional space of these words such that the distances between the words in this high dimensional space that captures this notion of closeness. And the technical term for this is word embeddings. Now, I cannot show a 100-dimensional space on a 2-dimensional PowerPoint slide. So here is a 2-dimensional approximation of 2 word embeddings. On the left side, we have some English words, numbers and animals. And on the right side, we have the Spanish translation of the same words. You can see that there is an isomorphism in the 2 word embeddings. And if we have the coordinate of horse and multiply it with a transformation, like we can somehow manage to link these 2 spaces in a way that we multiply it with the transformation, we get another coordinate, which is close to the word caballo, which translates to a horse. We can say that we are able to perform alignment-based machine translation. And if the same linkage function, W, can be again used where we can get the coordinates of cat, we multiply it with the transformation, and it maps to gato, which is the Spanish translation of cat, we can say that our machine translation method is generalizing to a lot of different words. So alignment-based word translation using machine learning works this way. We have word embeddings of 2 monolingual corpora of 2 different languages. Say if we are trying to translate English into Spanish, let L source be English and L target be Spanish. And then we have a small set of example word pairs. We somehow have to learn this linkage function. So we need to know which points in space 1 maps to space 2. So in case of English and Spanish, we will have word pairs like hello, hola, fish pescado, thanks, gracias. And with the help of this example, the goal is to learn a transformation such that once we have the embedding of the source word, if we multiply that with the transformation, we get the target word in the target embedding space. So mathematically, this is just like let L source and L target be 2 languages with vocabularies V source and V target. The translation scheme from language of source to language of target computes a transformation W and takes a word W source that belongs to the source vocabulary as input, and it outputs a single word translation W target such that the target word belongs to the target vocabulary. And of all the words in the target vocabulary, if we take the source words embedding and multiply it with the transformation, it is closest to W target in the target vocabulary. And cosine distance is used as a standard distance metric. All right, so now we are ready to describe our proposed solution. Again, this would be easier if we take like CNN, more like a liberal news network, and Fox, more conservative news network, as examples. We assume that the 2 subcommunities are speaking in 2 different languages, language of Fox and language of CNN. Now, if you think about US English and British English, we can assume that they are speaking in 2 different languages, and there are certain words, say flat, that would translate to apartment. But in this case, these 2 communities are speaking in US English. So when we say that we translate each word belonging to language of CNN into language of Fox, in an ideal world not fraught with polarization, all words should translate to themselves, like apple or tree in language of CNN should translate into apple or tree in language of Fox. Here, however, we focus on word pairs that do not translate into themselves, and we call them misaligned pairs. When misaligned pairs appear in similar contexts, they often signal political and ideological disagreements. So in this table, the left side are comments from CNN news videos, and the right side are user-generated comments on Fox News videos. You can see that over and over again, Republicans and Democrats, the 2 political parties in the US, they appear in almost mirroring context, like Republicans are the greatest threat to America, Democrats are the greatest threat to America. Republicans are traitors, Democrats are traitors. I'll never vote Republican again, I'll never vote Democrat again. So no wonder why a machine translation method that doesn't understand that these are two different political parties, it will just think that Republicans in CNN English translates to Democrats in Fox English and vice versa. So basically, our process is quite simple. We have two sets of word embeddings, say Fox and CNN. And last time, when we were trying to translate from English into Spanish, we had to create a bilingual lexicon where we had pairs like hello, hola, fish, pescado. In this case, we are translating English into English. So the way we addressed its bilingual lexicons is we thought that no matter how polarized these communities are, stop words like and, or, about, they will mean the same across both languages. And so our bilingual lexicons are just and, about, and we use these words to align the two word embeddings. So basically, if two communities are ideologically very aligned, there will be fewer mistranslations. If two communities are ideologically very misaligned, there will be more and more mistranslations. So just by counting how many mistranslations we find, we can actually quantify how similar user discussions of these multiple communities are. So essentially, what we are trying to do is similarity between these two languages is how often one word translates into itself and divided over the size of the vocabulary. So if it's 1, that means the two communities are perfectly aligned. And if it is close to 0, then the two communities are not at all aligned. So before I talk about the quantitative results, the qualitative results are also very interesting. So these are misaligned pairs when we try to translate words from language of CNN into language of Fox. Remember that each of these words should have translated to itself, but they did not. If we look at the political entities, we see the usual suspects like Democrats, Republicans, or Dem Republican. We found a misaligned pair, Kushner-Burisma. Jared Kushner is the son-in-law of the former President Donald Trump, and Burisma is the oil company with which Hunter Biden, the son of current president, has a lot of controversies going on. So you can see that this is basically a tinge of nepotism is present in this misaligned pair. If we look at the insults, Trump-tards is basically a portmanteau word of retard and Trump supporters, and snowflakes are another insult term for the Democrats. And you can see that these two are forming a misaligned pair. So when we looked at the ideological section, we saw, again, liberals, conservatives, leftist fascists. But what we were very shocked to see was KKK and BLM forming a pair. This was a very disturbing result. KKK is a white supremacist organization, and BLM is a short form for Black Lives Matter. So we were completely shocked, and we wanted to even check if this was happening for real. And these are actually example comments. Again, the left side are on CNN news videos, and the right side are Fox News videos. We can see that indeed, KKK and BLM did appear in very similar context, and that is why this mistranslation happened. So this result actually generated it's a very shocking and disturbing result. It generated quite a bit of interest, and the finding that the left and right speak so differently these days that machine translation methods that are actually designed to translate truly different languages like English and Spanish, that can be used to translate these left and right political and ideological views was also something that got quite a bit of attention. Yes. Yes, yeah. So this is just like we are training word embeddings on them. And I think whatever are the standard parameters for fast text word embedding, we just use that. Yeah. So now let's look at the quantitative side. This is basically pairwise similarities between different news networks languages, and higher value means higher similarity. So if we focus on language of CNN, we see that CNN is closer to MSNBC. It is more similar with MSNBC than Fox. If we look at language of Fox, we find that Fox is closer to CNN than MSNBC. And finally, MSNBC is closer to CNN than Fox. So if we combine all these three observations, and if we put MSNBC on the left, we get MSNBC on the left, CNN somewhere in the middle, and then Fox somewhere in the right, which actually aligns to what we usually know is true, is ground truth. On a more serious note, we actually investigated how fringe news networks played a role in the Capitol riot. And in addition to multiple news networks, we also considered former President Trump's YouTube channel. So it was not banned at that point of time. So we could get its user discussion. And we wanted to see what is the language of Trump followers, what is it closest, which news network it is closest to. So we found that language of Trump is closest to language of News America, Newsmax, and One America News Network, which are, again, the two news networks that were peddling maximum amount of voter fraud information during the 2020 election and its aftermath. So this work also appeared on the front page of New York Times for a different investigative journalism effort, where this method was used to understand election deniers, like Republicans, Congress people who denied the election if their language is different from Republicans who did not deny the election. So this work has also found applications there. And the key takeaway point of this work is it is very efficient. You don't have to read millions of comments. The moment I say that solar in language of CNN translate into fossil in language of Fox, you immediately know that there is a debate surrounding the energy issues. Or if I say that mask in language of Fox translates into muzzle in language of One America News Network, you immediately know that there is a community that thinks that wearing mask is interfering with our freedom of expression. We also went beyond single word, and again, we found a very shocking and disturbing result that Black Lives Matter in language of CNN, it is closer to All Lives Matter in language of Fox than Black Lives Matter. In a more recent follow-on work, we have used the same method to understand political polarization in South America. And there also we found that we can find mistranslations, pairs like comunismo, fascismo, or socialista, capitalista, indicating that our method can transcend to different languages, different social media platforms, and also it can inform us about different political crises. So the socio-linguistic impact of this word is different words may be used in near identical contexts in different communities, and such words may inform us about fundamental differences between the communities. And this is the first line of work that actually connects machine translation with the literature of polarization. And it shows that machine translation can provide a powerful, interpretable, and quantifiable framework to understand polarization. Now, the idea two is about how to quantify differences between small-scale text data that is focused on just one topic. So we worked on a recent paper where we tried to characterize US news media portrayal on policing. And there were three momentous events that happened in US. One was George Floyd's murder, the protests and civil unrest, then the Capitol riot, and then Derek Chauvin, the police officer, his conviction and sentencing. And we again focused on three major US cable news networks, but unlike previously, we focused on user comments. This time we were just focusing on news transcripts. And we had a data set of nearly 120K sentences with the keyword police taken from the news transcripts from Fox, CNN, and MSNBC. Now, if we take a closer look at the data, This is a comment, this is a news transcript sentence from MSNBC. Unarmed black person committing no crime shot and killed by police. This is an example sentence from Fox. It's the media activist class that took a tragic incident and cast all police as corrupt, which caused the Ferguson effect. And this is another sentence from CNN. We have seen the image of the Capitol police officer who led that mob away from the Senate chamber. So if we manually inspect, we see that there are some systematic differences. But human biases on contentious social issues that are well documented. So how can we quantify these differences using automated methods? Machine translation-based method, the one that I just presented, it won't work because these methods are extremely data hungry, as our previous speakers indicated. So what we did, we cast this as a classification problem. So typically, text classification is thought of like a goal, where you're trying to predict if an email is spam or not spam, or if a social media post is hateful or not hateful. But if we have a classification challenge where we have very high accuracy in our performance, we can infer that the two classes are separable. And a low accuracy can inform us that the two classes are not very distinct. Take the case of spam or not spam. If the email is like, the King of Oman wants to transfer $10 million to my bank account, and I just have to send 10K to initiate the process, I always wondered that why don't they send me 9,990K and just like deduct the 10K at the source. If the email is like that, then it will be very easy to classify it as spam. But if the email is very carefully written, like there is a journal which is inviting my paper and they have like a very short review cycle and I just have to pay like some processing fee, probably I'll fall for that. So basically what we are trying to do is like we are considering this as a classification problem, and we are trying to identify if we can tell Fox News and CNN apart just by looking at the police-related sentence, or if we can tell MSNBC, Fox News, or CNN and MSNBC apart. Now, there is one catch, that is, suppose all the MSNBC news anchors say this is a crazy incident, and all the CNN news anchors say this is an insane incident. So if those kind of quirks are present, then the classification model will be still able to predict between CNN and Fox very easily. So we need a control group. And the control group is, we try to see if any sentences in Fox and CNN is easy to predict. So essentially what we do is we take 5K sentences from each news outlet, we train on 80% of the data and 20% of the data is left for test. And we repeat this experiment. Once we only focus on sentences that has the keyword police, and second time we consider any sentences. And effectively what we find, this is like a pair-based classification result. If we focus on the top numbers, these are classification accuracies between these news networks when we are only focusing on sentences with police. And the bottom row is basically classification accuracy between news networks when we consider any sentences. So we see that the classification accuracy between any sentences is close to chance. However, the classification between police-related sentences is higher between Fox CNN and Fox MSNBC, with the social conclusion that reporting on policing on Fox News is considerably different than CNN and MSNBC reporting on policing. Now, I just have 5 more minutes, so I'll quickly talk about a very recent AAAI 2023 paper that we had, where we introduced the idea of anti-content sampling. So what is anti-content? Is basically naturally occurring adversarial examples that can blindside a content classifier. And here is one such example. This is basically a chess discussion forum post, and a hate speech detection system thinks this is hate speech because black, white, attack, capture, threat, this kind of words are present. So what we did was we took 5 well-known COVID-19 misinformation datasets, and we trained models on them in this paper. And then we ran these models on a large-scale social media data of 2019. Now, before COVID happened, there cannot be any COVID misinformation. So ideally, all these classifiers should have predicted 0% COVID misinformation in the 2019 dataset. But we found that there are models which predicted as high as 62% of the pre-COVID era social media posts as misinformation. So what we learned is we can use this idea to train a model on a COVID-19 misinformation dataset. Then we can run inference on 2019 unlabeled pool. Whatever it is predicting as misinformation, we know for sure that this cannot be misinformation. So we can augment the dataset by flipping the labels as challenging negatives. And we can just keep doing that up until we reach 0 positive prediction in 2019 data. And that's this idea of anti-content sampling. So with this, I want to tell all these early career researchers that we keep seeing a lot of complex models, complex ideas, but there will always be room for simple ideas that can be very effective and that can be useful for the science community. Keep looking for them. Thank you.
Thanks a lot for that cool talk. My question to you first up is about the first idea that you spoke about. And I was wondering whether you looked at it through a temporal lens. When you're looking at polarization, I wonder, I mean, because you clearly have a very useful approach that you can apply in so many different contexts. But when you were looking at comparing Fox and CNN, for example, did you also try to look at this through a temporal context? Because I'd imagine that because of the fact that bipartisan laws or bipartisan, coming together and working together on different things can take place. I wonder whether you can also detect the time at which CNN and Fox are miming the same tunes and when exactly they differ, and whether that can tell you a little bit more about the dynamics in general.
Yeah, so this is a very interesting question. We did look at temporal evolution, and we found that polarization is increasing, but it's still such a short time span, like 2014 to 2020. And of that also, we do not have enough data up until 2018. So I think that's a good research question to look at sometimes in 2030 or sometimes around that. With more data, we will be able to actually quantify that. And it's a very interesting thing to look at. And secondly, if specific incidents are changing it, that will be these are word embedding based methods. So they are extremely data hungry. So when we have explosion of discussions, maybe then we will be able to slice and dice the data in any way we want to, and we can start looking at those kind of questions. Yeah.
Thanks, Ashique, for the wonderful talk. So about this last part, so I was wondering whether you checked what were the pre-COVID data points that were marked as misinformation.
Correct.
I guess you did. So were there any patterns? Were there something generalizable about them?
So what was happening, it was just doing shortcut learning. Suppose it learned that something is a hoax, is an example of COVID misinformation, this COVID is a hoax. And then if you input this impeachment is a hoax, it also thinks it's COVID misinformation because it's getting swayed by is a hoax phrase. So this kind of phrases are actually creating, triggering these errors. So there is a pattern to it. And as we kept doing this pipeline, and the best thing about this pipeline is it's annotation free. I mean, the annotation is coming for free. This is almost like active learning, but active learning without any annotation, right? And we noticed that it trips when there is a misinformation kind of post, but it is not dismissing COVID-19. It is probably dismissing the election or the impeachment, those kind of things.
Thank you.
Okay, so I actually have a question. My first question is the following: that the first talk is very interesting. I was wondering if you could use it to turn it around a little bit in the following way. That is it possible that I look at the same word and see whether their meaning is different to these two communities? For instance, the word American, right? The word American,
Yeah.
right, or the word patriot. Right? Can I use the framework that you have to see whether the definition or what they mean by that word is different in these two communities? Do you think that's possible?
We won't be able to do that because it will still map to itself. No. If it maps to a different word, yes, we will be able to detect. For example, un-American and unpatriotic actually created a misaligned pair, which is like very typical ways the liberals say something is not befitting of the US and the conservatives say something is not befitting the US, like un-American and unpatriotic. So I think we will be able to find those kind of words. Essentially, it just means that when Republicans maps to Democrats, is basically you have a political party's image in your head that is disrupting the country and another political party's image in your head that is the true savior. And it's just for the liberals, that party is Democrat and the disruptive one is Republican. And for the Republican, it's the other thing. So it's just like how you think about things. Those things are getting mapped.
Cool. Thank you. Any other questions? No, I don't see any. So, yeah, thank you for this great. So I have a question. So how much bias is Facebook or Twitter?
This is YouTube.
Can you use this technique to see what is happening on Twitter or Facebook?
Yes, as long as we have like two different data sets, like the South American protest paper that we had, we were working with Twitter data, but one part of the Twitter user base was supporting the protest and one part of the user base was against the protest. And when we started looking at linguistic differences between these two groups, we could find that. So it works.
Yeah, I understood that. That will work. But I'm telling Twitter as a whole. If I think Twitter as a whole, and if it's not like two medias, just one media.
No, it won't work. Because what it is trying to do is like, it's trying to find how different two communities are. Like within one community, it will be just the same.
Then tell Twitter is a neutral media?
No. Twitter, we cannot say Twitter is a neutral media. It is just
how will a neutral media look like? That's also my question.
How would a neutral media look like? That's $1 million question. I guess like if we have like 10 or 20 different news networks, and once you have the pairwise distance, you can actually compute those distance and project them to a 2D space. Then whatever news network in that visualization is in the center of the whole 20 or 30 news networks, that is the one that is closest to the center. So I think that's how we can find what is a neutral network. Correct, yeah.
Just to follow up on that, you also showed us some numbers about the polarization and, well, the similarity, right, according to your approach. And the numbers were still quite high, right? So if you were to just look at it, I think 86 versus 90 something, right? Of course, and I think the difference is attributed to those misaligned pairs, right?
Correct.
So isn't it also a function of where exactly the misalignment lies that would somehow dictate how far apart these two networks are? For example, if CNN is misaligning carrots or apples with oranges, people probably wouldn't really care. You see what I mean? So
So this is actually a limitation of this work where we are treating each mistranslation as equal. I mean, KKK BLM is definitely not same as Trump Turd and Snowflake, right?
Yeah.
So I think a future line of work could be better quantifying like what it means, like when KKK. I mean, one question we kept facing in the media that is there anything that you felt good about? We said that democracy in all news networks were still translating into democracy. So that was the only good thing. So if democracy starts translating to something else, then I think that's a much more serious thing than any other mistranslations that we have seen already.
Yeah,
right?
I guess like aligning what you have with like a toxicity dictionary of sorts could be like a low hanging fruit.
Correct.
But
Yeah.
very cool idea.
Exactly. Yeah.
In the interest of time, we'll just wrap up the question. Thank you for proposal. And there's a small token on behalf of Anticontent and in the thank you. Thank you.
Oh. Yeah.
Just check once is it working.
Our next speaker, I just speak loudly. Our next speaker is Dr. Prasenjit, who's the Senior Vice President of Innovations at Merlin Mind. And in this role, he looks at various problems in the intersection of AI and human-computer interaction. He also specifically looks at these are multimodal interactions and language models, large language models. Prasenjit has a background in information theory and he did a speech from KFL and he delivered standard patents as well as peer review. So welcome.
Thanks.
Hello. Yeah. Thanks. Good afternoon, everyone. And thanks to the organizers for having me. I know it's very difficult after a great lunch and me standing between you and the coffee. I'll try my best to keep you awake. This will be a slightly different kind of flavor in the sense it'll be more like your industry track that you see. But one of the things I wanted to bring forth with, by sharing this experience is that which I think many of the speakers earlier in the morning, right, Monojit, Mohit, DJ, all have set the tone for what it takes from a technological breakthrough to actually making it work for real use cases. I think that's really what I want to stress on and just use this as an example to share that even though we have known, ASR and voice-based assistance for a long time, but yet it took us a lot of heavy lifting to actually enable that for classroom and education applications. So first, we are a small startup. So we are not like Microsoft or Google that all of you know about. So I'll brag a little bit about us before I go into the talk. So we are an 120 people startup based out of New York City, but we have employees all across the globe. We are a remote first company. And one of the key things that we work on is to enable making workplaces more efficient using multimodal interfaces and AI-enabled automations. And our first venture is to make classrooms more efficient, which we are doing with the use of an AI-enabled digital assistant. And the key thing is that we are trying to make the teachers' workflows more efficient. And I'll talk more about what I mean by that. And the second is untether the teacher from the front of the classroom, which is always, if you look at any classroom, the first thing the teacher has to go is to go to the laptop and do what they want to do and go back to the middle of the classroom and talk to the students or they, carry out their instructions. Okay, so the outline of the talk is, I'll give a brief description of what our use case is, the challenges that are there in a classroom that we faced in designing this particular digital assistant, and then our approach, a small glimpse of the approach of what we did for our voice and the NLP pipeline. Okay, first video of what the teachers tell about our assistant.
Teaching isn't a job for me, it's a calling. But what it means to teach keeps changing, just like the world keeps changing. Technology is a huge part of what I do now, and that isn't always easy. Hey, Merlin, pair my laptop. Merlin is the perfect assistant. Being able to control the technology with just the sound of my voice is magical. Hey, Merlin, open day one presentation. The less that stands between me and my students, the clearer our connection can be. And that's freedom for me, freedom to teach.
Okay, so what's happening here? So teachers at the moment, right, if you look at any classroom, there's huge lot of technology, right? Starting from hundreds of different education applications that the teacher use. And here, our primary target is the K-12 classrooms. You have hundreds of different apps, subject-specific apps. You have, apps that are particularly about some attendance taking or LMSs, all of that. And then you have all these different devices that are in the classroom, right? Starting from document camera to a microscope, to a laptop, to a smart board, all of that. And all of this requires orchestration on part of the teacher. For example, if the teacher wants to shift the, the display from the laptop to a document camera, she has to come back and switch, flip a switch or do something, right? Now, what this entails is that the teacher is, as part of the instruction, they are constantly distracted by all these different things they have to do. In spite of delivering the instruction to the student, they have to go and manage all this technology and all the workflows that are beyond just the instruction or delivering learning to the students. So what did we do? We designed an assistant which essentially integrates all the infrastructure and the devices and the applications that are in the classroom, it understands what these applications are and integrates all of that into a seamless voice-enabled application, voice-enabled experience. And what it also does is untethers the teacher from the front of the classroom, which means all you have to do is to, as you saw, that just say, hey, Merlin, and say what you want. And Merlin essentially orchestrates all of that behind, in the background for you. For example, things like I worked on a slide on photosynthesis last night, and I want to bring it up. As if you did the traditional way, you have to go to the Google Drive, look for that presentation, bring it up, and then put it in the slideshow mode. Here, all you have to say is, hey, Merlin, find my videos on photosynthesis or find my presentation on photosynthesis. So that's what it really entails. It makes things, it creates this voice-enabled shortcuts for teachers, for their classroom workflow applications. So why are voice interfaces so difficult in classroom? The first thing is the noise, right? The noise level in the classroom is very different from what you see generally in your homes. And I'll show you an example of how it feels like what the microphone is actually hearing. is there's a huge amount of babble noise. There is continuous conversations that are happening. Kids are, shouting, talking, all of that, right? So it's a very unforgiving environment for voice-based application. The other important part is it's a highly regulated industry. In education industry, you have the COPPA, the FERPA, the SEPA, all different regulations which require there are PIIs you cannot collect. For example, you cannot send voice samples to the cloud when you have, when you're operating any such device in the classroom. For that, you have to be very careful that it's not like any other voice assistant that you can send it to the cloud, bring back a recognition and use it. There's huge diversity of network in the schools. For example, and here for right now, our primary market is US, UK, and Canada. Even in those kind of developed geographies, you have schools which are in New Mexico, which have a completely different kind of bandwidth profile, network bandwidth profile compared to a school in somewhere in California. So you have to deal with those kind of limitations also. And the most important thing is that we expect voice applications to respond immediately. And it has been found across many studies that when you do a web-based interaction, people are forgiving to a second or 2 seconds of delay, but they're highly unforgiving to when you have a voice-based response or a voice-based interaction. So our AI solution, essentially what it does is that it is designed as an edge device, which provides real-time responsiveness, which means that we have designed this with very high computational resource on it, so that it can process all of this in real time. It is privacy aware in the sense that we do not send the voice samples to the cloud, and it can be very, very tolerant to network fluctuations. So this is what the device looks like. Of course, this is the broken down view. We have it in our stall. You can have a look. So this is a 7 microphone array device, which means it can beamform to exactly, you could be 10, 15 feet away and it can still hear you, or you can also use the remote to talk to it. And so it has been designed with a very high sensitivity to, from where the teacher is talking to. We have an amazing pipeline of signal processing. I'll show you the sample of how it reduces all the noise, background noise in the classroom. And then it has a 6-core CPU, a GPU, and an NPU in it. So, a new NPU for neural processing unit for all kinds of AI processing that may be required on the edge. Okay, so just to give you an example, right? So what did we go about doing, right, to solve this whole the recognition, speech recognition problem, and then the natural language understanding problem. So if you look at a simplified voice pipeline, typically you have the wake word recognition, which is when I say, hey Merlin, or I say, hey Google, these are the wake words. You listen to the command, and then you have to identify what that is meant to, which is basically about understanding the intent and then translating that to the, the context of the application. So what are the different things that we're doing, right? First, as I said, right, just at the microphone level, the 7 microphone array, we do a huge amount of noise cancellation beamforming there to make sure that we are not capturing unwarranted noise. The second is, we use a generic ASR. I mean, we use Google ASR, but we do a lot of customization on the language model itself to make sure that we get, domain-specific, robust understanding of what the teachers are saying. We use, again, our own post-processing to reorder, and I'll show you example of what, how some of these things can cause a lot of confusion. Is we do this reordering based on the context in which the teacher is giving that particular command. And then, of course, we have our NLU pipeline, which we don't want to make it very customized, because you need to ensure that you can club in a huge lot of different applications that come out every day, different applications like Desmos, Zoom, a lot of different applications keep on coming every day. And then you need to integrate your natural language understanding pipeline needs to still process those intents. And then, you prioritize it to your application. So here's an example. The teacher said, pair my laptop. And this is really a real example. What the ASR recognized is, sell my laptop, where is my laptop, pair my laptop. These were the three, ranked list of the recognition, right? So based on domain-specific reordering, we know that, yes, currently the teacher is teaching a particular subject, right? She's in that state, so most likely she's not going to sell her laptop, right? So she's either going to pair her laptop, or maybe at the best case, she may say, where is my laptop, right? But definitely not sell my laptop. And then you map it to the intent, and then you have the application. So which means that if I currently, for example, if I have an application which is a math application open, you very well know that the commands are more related to maybe you can hear a parabola, you can hear a square, you can hear something, but you're not going to hear something on rock formation, right? So these are this other set of information that we use, the context that we use to ensure that we get a very high level of accuracy for these kind of applications. So this is the example I was saying, right? That how we remove a lot of different, the background noise. So first here, this is the raw audio. Did you even hear the teacher? No, right? So there was a teacher who was talking there. So now hear this.
This is a test of the DSPC processing. There is kindergarten noise playing from the noise speaker. There's 80 decibels in that microphone arrays.
So our signal processing pipeline essentially removed all that babble noise and focused only on the the speech that you just heard is about from the teacher. So that's the kind of heavy lifting you have to do when you really get into these kind of environments. So yeah, just a quick flash of what for example, I told you, right? There, for example, reduce becomes radius, zoom in becomes zoom in, right? All of that, but we are still able to get almost 4 percentage points of higher accuracy, right? Using some of these different pull-up mechanisms. These are just something, few comments that the teachers tell. And one of the main comment is the untethering part of it. That means they are able to spend more time with the students in between the students rather than being stuck at the front of the classroom. Okay, I cannot leave this place without talking a little bit about transformers, right? And all of you, you'd be bored to death by the time this conference finishes, but definitely, right? I mean, all the speakers, right, have been talking about the same, theme, right? That there has been a great technical advancement with these new foundation models. And there's no doubt about it. We, as someone is saying, right, we haven't seen that kind of, I would say, the generation capabilities that these models exhibit in a long time, right? But the problem is that these are not something that you could use in applications as it is, right? And you see already all the RLHF work, right? Reinforcement learning from human feedback work that is essentially trying to make this more usable for real life applications with ChatGPT, and then you have the human loop and Carper AI looking at more an open source version of InstructGPT and so on. But that's one step of that lift. But you still see ChatGPT giving very authoritative answers, which seem very real, but then are totally fake, right? So these things become very critical, especially in education application, right? You cannot let kids think, that fakes, something that was told by a machine and which is fake is for real, right? You're basically dealing with, a level of an age of learners who are very impressionist. They believe what they hear, right? It's not, they're not even adults. So here, the next level of lifting that is required is to really get into, very domain-specific training, fact-checking, adversarial filtering, right? To make sure that these are all, and again, domain risk poster is very important, because for healthcare and education, the level of domain risk that I can tolerate is not the same as maybe for something like I'm just writing an essay writing tool, right? The levels of tolerance of risk are very different. So we have to, that this is the next level of innovation that's required, is to really get to, very domain specific understanding of what does it need to take these different models and these breakthroughs that we have closer to where those applications are. And each of those applications, the domains themselves, would be huge amount of work, because they have completely different, and you saw the, the healthcare domain work that DJ presented, and then what Manojit presented, right? Some of his work. I mean, these are non-trivial, and hence, I think as a community, right, both industry and academia, we have to start to get closer and closer to the applications to really understand the nuances of it, and which is where at least in my belief, will the next set of breakthroughs will come from. Okay, so to conclude, domain-specific AI solutions require very, very unique customizations. And I just presented one example of it, but we have many, many more examples, and you guys have perhaps experienced that yourself. Making voice work in the classroom environment is extremely challenging, both from regulatory point of view, as well as from the noise, the level of noise environment that exists. And we have developed this, the first product of ours, right, which is a voice assistant for the classroom. And our goal is that in future, we continue to leverage some of these advancements of AI, right, that are happening to start to automate more and more from not just the classroom, but many other, work environments. And I think this is a great opportunity as a community to leverage all these advancements to the different, to take all these advancements into domain-specific AI applications. With that, I'll conclude here, and thanks for listening. Thank you so much. Do you have time for a few questions?
Thanks for the talk. So my question is, how do you identify a speaker when only just one person is speaking? So is he that or she is the teacher?
Yeah, that's a very good point. So what happens is that, this whole babble noise, right, that I was talking about, essentially forms a particular, almost a pattern, right, of how, when children speak, right, and they speak all together, it almost gets drowned if you normally hear, but when you do signal processing, right, on it, you can actually see there's a kind of a whiteness in that noise versus when the teacher is actually saying something. So that's what we take advantage of, to say, okay, there is, even though to a normal human ear, it seems very, very, that I can't hear anything, but you can still get some of that out of the signal in a way.
Okay, hello, sir. Yeah. So is there any personalized wake word for the Merlin? Like sometimes some students just mess around with the teacher and say, Merlin, shut down the computer.
Yeah, that's a great, and this is something which actually, we have seen that in real, and that's what teachers want, that in fact, kids play a lot of prank. and they have, played a lot of pranks. So teachers actually wanted a lock button on their remote. So which means that when they don't want, they can lock it so that it does not listen to, commands. So yes, one is the speaker identification itself could be great. So in the sense that the teacher, when only he or she speaks, can it activate? But other is for the teacher to lock it down when he or she wants, when it's not in use. But yeah, that's a great thing, a great observation, and it is for real. This has happened.
Hey, hi, Prasenjit. Yeah, very interesting talk. Firstly, I think very sort of relevant application. So my question was around the customization. So given the challenges with data that you earlier alluded to, how did you go about doing the LM customization? I mean, collecting data for LM customization. And a related question was also, I mean, how do you sort of continuously maybe, refine or, do this continuous LM customization, And third, also related was, did you also look at any acoustic model customization along with LM, or was it just focused on LM customization?
Sorry, I didn't understand the third question.
Third was, I mean, did you also do any acoustic model customization?
Okay. Yeah, great question. So, one is, let me start with the third one. It's a straightforward answer. So we do not look at the acoustic level customizations because we directly leverage Google's ASR, right? So for us, it's mostly at the language model level and not at the acoustic level. So it's simply because we don't have our sort of, I would say, our technical capability around any of the acoustic level modeling side of things. Did that answer your question?
Sure. Yeah, I think some of these out of the box services do allow acoustic model customizations as well. So I would just, but anyways,
right. So and then on the customizations, right, as you said, you have to continuously look at. So for us, the biggest source of that information is our device sending every interaction that the teacher has to our cloud. So we continuously look at which are the features the teacher is using the most, which features are the teachers struggling with, because we can measure it from, for example, the teacher may sometimes just say, oh, this is so frustrating, right? Now that itself is a clue for us to say, okay, there is something wrong here that we need to fix. Or there are some features that are inefficient in the sense that, you have to, instead of saying something, maybe I go and click something, right? All of that. So for us, that constant stream of data that we get from the field, from our devices, is actually one of the biggest inputs to our next level of customizations that happen.
All right.
So,
hello.
So here.
It's a nice talk. Just I have one small question. So is there any predefined set of comments that a teacher can ask, like open the slide or open last slide kind of things? Or if periodically teacher can ask new comments or some of the things, then the model needs to be retrained again?
I got your first part. So like open the last slide and so on.
Yes. So there is just a set of comments that is like only 10 comments or 15 numbers.
Oh, yeah. So we maintain the state. So for example, if your browser is open, right, we can maintain the state of how many tabs you have open, right? We can maintain the state of where, what applications are open. And as you said, right, which state these applications are. For example, if I say go to the previous slide, right, or go 10, so I'm watching a YouTube video and I say go 10 seconds behind or go 10 seconds forward, our assistant understands all of that, and it can simulate all those actions on slide or an YouTube video and so on.
Okay.
Yeah, sir. Yeah.
Sorry.
Okay. Yeah. So how does the system know about the context of subject being taught? Like which subject is where teacher is teaching, like so it's social science or mathematics, so that system can know about the type of words that the teacher would say.
Yeah. So see, for example, right, I mean, whenever some application is in focus, so for example, I'll give an example of Desmos that we have used quite a bit, right? I don't know whether you guys are familiar with Desmos. So Desmos is this mathematics application, right? Where you can draw graphs, run some. So when you open an application like Desmos, you have already set the dictionary, right? So in the sense that if that is in focus, that means I'm looking at a math as an application, right? And hence the commands that come from my ASR, if there is something that there's a misrecognition and something, as I said, right, rock formation comes in, I'm very likely going to reject it because that's not something which is relevant to the current application in focus. But there may be other kind of things. For example, I may want to bring some application which is in the background to focus, right? So those are the ones that I need to still listen to. So it's a delicate balance of what you want to reject because it's not in focus versus you keep on still, because voice is one great modality in the sense that if something is not visible on the screen, right, you can still bring it out, which you cannot do whether you're in a touch or a mouse.
What if the teacher want to give an interdisciplinary example or something?
Yeah. So you know, if the teacher is that's again a process of how you bring accuracy versus address some corner cases. So if we observe, right, that the teacher, there's some particular command or some things that the teacher is saying is not being recognized and it's happening multiple times, then we realize that, okay, maybe there is a utterance, which is, as you said, right, interdisciplinary in nature, and it needs to be addressed. So for us, this device being connected to cloud is very easy for us because we can push any of these updates anytime across all the devices that are currently on the field.
Thank you, sir.
But great question. Thanks.
Hello. Here. So you said one of the example was, let's say the teacher asked to open week 1 presentation.
Mm-hmm.
So does the naming convention have to be followed when they are asking, or will this be inferred? So let's say I want to open particular topic, photosynthesis,
Mm-hmm.
but this is referred in multiple slides. So
Mhm.
can I, as a teacher, can I refer to just the topic and then this will be inferred and it can be opened?
Yeah,
Or
so-
a naming convention?
Right. So some of these commands, like I said, right, some of these commands are meant for background operation, as you said, right? Bring up my slides on photosynthesis. Obviously, it is not in the front, and that's why I'm asking for it. So many of these will operate even if they are not in current focus, simply because it is meant to basically bring that information out from the background.
So how does it search for this information though?
Oh, okay. So
From
what
your
it,
files?
yeah. So if I say, for example, I said, bring, show my slides on photosynthesis, right? What it's going to do is basically look for your most recent set of slides that you have worked on, right? It knows because our device is, logged into your Google Drive. And here the assumption, because most teachers now use Google Drive and Google Classroom, right, as an application. So it goes into Google Drive, looks for the most recent ones, and it has already pre-tagged, those slides based on the topics that, the essential keywords that it has in it. And hence it can bring up your slides that you have. If it's something which is really old, then it may fail. But the ones, if it's a recent one, maybe in the last 3-4 days you've worked on and there's a photosynthesis in it, right? And it can bring those up. And if it finds multiple of them, it will show you a list of, let's say, 3 or 4, and you can say the first one, or you can say the second one. So you can get into a next turn of conversation with it.
Okay, so it can be done automatically.
Yeah.
Thank you.
I have a question. Firstly, a great talk and a great AI application. Kudos to you and your team. So as you mentioned that this application, like, it needs to handle various bandwidths, and it has to be latency should be as low as possible. So my question is, like, let's say when a teacher is using this application and he or she just instructs a command, and at that time a very bad bandwidth variation takes place. So how does the system tackle that?
You mean there's a bandwidth issue?
Yeah, it's sudden drop in the
bandwidth.
the
network drops or something.
Yeah, so
Okay.
that the command is like not completely understood, or it is partially understood, something like that.
Okay. So first of all, the recognition, the speech recognition part, we do not send it to our cloud because, as I said, right, because of regulatory requirements, we process it on our system, right? Now, if in case, say, for example, from a network point of view, but our natural language understanding happens on the cloud, right? And so once that recognition has happened and my network fails, right? There's, you're most likely you're not going to get the intent, right? So one way to, at least right now, what we are addressing, so we'll, in future versions of our device, we'll have things that are more distributed across cloud and client. But right now, what we do is that we, when such a failure happens, right, the device comes back to the teacher and will say, didn't get what you said, could you repeat it, and so on. Because one of the problem is that sometimes there is a network failure, or sometimes it can also be that our NLU did not even get it, right? So once it processes, so all these different, so our recovery mechanisms right now are pretty simple in the sense of, say, asking the teacher to repeat it at the moment.
Thank you.
Should I? Thank you for the great talk, Prasenjit. So I have a couple of business-oriented questions. The first question is like, why did you pick this particular untethered to the desk as a scenario? Is that the biggest frustration expressed by the teachers? I mean, when I was thinking, I was thinking of other scenarios, maybe like school shootings, which are even more life-threatening. So what was the rationale behind picking this scenario? And the second question is how does this, what is the biggest differentiator of this technology from Siri or Alexa?
Okay, great question. Thanks. So yeah, in terms of the friction, right? I mean, at least before we started this company, one of the things while talking to a lot of teachers, and that was back when few of us were at IBM Research, was that teachers, in the classroom, right? Teachers don't want to deal with technology, right? I mean, even though they are forced to. And one of the things they have consistently expressed at the time was that, I love technology, I want to use it, but I don't want to deal with the complexity of it, right? So that's one. The second is the teachers felt that just when they're tethered to the front of the classroom, essentially means that they're having to deal with technology, because I'm going into the laptop, I'm pulling up my slides, I'm doing, changing the document camera to this. And so they almost connected this whole being tethered in the front of the classroom near the laptop as dealing with technology, right? So in a way, what we thought, okay, so there's a perception issue, right? Maybe, that being in the front of the classroom may not have anything to do with that, but that's what teachers feel. And when we did our pilots, right, when we allowed the teacher to be away from the laptop, they felt very free, right? In the sense that they're able to move their hand, talk to stand right next to the kid and, say, kid asks a question and you say, okay, bring up a video on earthquakes, right? That's it. You're not going and searching anything, right? So that's what really clicked with them, right? And that's what they feel is very powerful for them. Now, your next question, right? How is it different from Alexa and Google Assistant? The biggest, the main difference is that Google Assistant or Alexa, right? They are very generic assistants, right? Voice-based assistants. And if you start to put them in these very specific environments, right? There are huge issues of, them, you'll have misrecognitions, you will have a lot of the time, the NLU doesn't work properly, all of that, right? And that primarily comes from the fact that they're not meant to, a particular domain knowledge, right? And again, we are very forgiving when I say play a song or buy me a whatever, something on Amazon, right? We are forgiving if it did not, but here when the classroom, the teacher is already stressed that she has to deliver a content, and then this guy frustrates her, right? Him or her, and that's the end of it, right? Nobody operates it, and we have faced that ourselves. Once the teacher faces a 1 or 2 times of mistake, they don't use the device again. So that's the kind of environment you're there. And second is, of course, the whole regulatory privacy part. We cannot send voice samples to cloud in a classroom, so which Alexa or Google does. So that's.
Sanjeet, thanks for the talk once again. And my last question, you almost created the best segue for it because you used the word privacy. You also mentioned how you're decoupling some of the issues by sending only a part of the information to the cloud NLG, and the ASR is happening client side, which makes a lot of sense. So what exactly are the nature of the privacy issues you still face?
Yeah, so definitely, voice is big deal, because these are kids' voices, right? You have that is being captured as part of it. The other is, if by inadvertently, right, we are leaking any PII that is not explicitly captured, but if you look at the text that is sent out, right, to the NLG, is there something embedded there? That's something we have to be very careful. And hence, even the commands that we allow are very carefully curated and understood, because without knowing, we may be leaking PII, right? So that's something which we constantly worry about.
So out of curiosity, is this actually something that gets regulated or audited at some point, or is it something you do from a responsibility standpoint?
Yeah, so very good question. So definitely as we get into school districts, we have to certify ourselves, and there are bodies which certify our product to say this is safe for schools, use in schools and in classroom, because most important thing is that we capture voice, and that's the reason we have to go through a certification process. Any?
So as you said that you don't send the voice samples over the cloud, so can you just talk about how is the deployment? What is the cloud infrastructure?
Yeah, so if to just simplify it, right? So the device essentially has the processing capability, right, to process the voice and do the ASR locally. Once you have the recognition, what you're doing is you're sending that whole string to the cloud, where our natural language understanding module is trying to convert it into an intent. So what I mean by that is, so for example, if I say pair my laptop, or get my laptop paired, right? All these are just variations of the same intent, right? The intent is pairing the laptop, right? So all of that is understood by our natural language understanding module, which once you have the intent, then you say, okay, and in this context of these applications that are open, what makes sense? Is there an application or something open here that makes sense? For example, if I say, for example, start a Zoom call, right? And I have no Zoom application open anywhere. I don't even have a Zoom application on my laptop, right? Which means that there's possibly been a misrecognition. So then we can correct it even more to say, okay, is there an application that's relevant or not? And then, so that's how it goes in different steps. But except the speech recognition, rest, all of it happens on our cloud.
Okay, so
did I answer your question?
Yes, so that means the model is deployed on the device. All the ML model, all the recognition model is deployed on the device.
Yes, the speech recognition part.
Okay,
yeah.
Okay, thank you, sir.
Yeah, do visit our booth and we can talk more. Thank you.
Thanks a lot. Thanks a lot for the example.
Thank you.
Yeah, providing. Okay, so let's take a 15-minute break, the coffee break, and after that we'll be back for two exciting tutorials by Dr. Abid Day and Professor Rishabh Iyer.